Well, dear students, in this video, I will be doing some question based on current, electricity, resistance, power, etc. Now, in figure here, in question 1, figure 2, figure 1 shows IV graph for a given conductor at temperature T1 and T2. Figure 1 shows IV graph for a conductor at temperature T1 T2. Here in figure 2, PI graph for again a given conductor at T1 T2. So what is higher, T1 T2 in figure 1 and 2? Which temperature is higher, T1 or T2? Question is this. You know resistance from this graph R equal to V upon I, and you also know that resistance of conductor increases with the increase of temperature. Is that clear? Resistance of a conductor increases with the increase of temperature. Now in figure 1, R equal to V upon I, for same I at T2 being higher than T1 by V upon I. Here this much V only, I this. Here it is V so larger, so it means resistance is higher at T2, hence T2 greater than T1. In figure 2, again R to V upon I, for same V, here I is higher. So in figure 2, for same V, I higher than T2. So in this figure, at T2, for same V, I is greater. So R is lesser at T2 and hence T2 less than T1. So they may ask anyway. So question of 1 mark have used Ohm's law as well as variation of resistance with temperature. So this way they mix the question, topics in a question of 1 mark. Now other question there. This is one question here. I think there is no need to write this question. I have spoken, you can write yourself. Now other thing here is, question is there कि a heater is marked 1100 watt and 220 volt. So what will be the power? Is the power produced by heater. At 110 volt. Dear student, listen me carefully. Any device marked, suppose it is marked 220 volt 1100 watt, it means it gives power of 1100 watt at 220 volt. If voltage varies, then power will also vary. Clear? You know formula for power produced by heater or any device, V square by R. So first it is 1100 equal to 220 square upon R. What is power if it is 110 square upon R? To P, here it is assumed that resistance remains same. Though you know resistance of filament vary with temperature, but we assume anyhow resistance same. So P upon 1100 equal to 110 upon 220 whole square. So it is P equal to 1100 into 1 by 2 square. I mean, 1 by 4. 1100 by 4 means 4 2 का 8, 4 3 का 28, 28 कितने वाट? 1/4 रह जाएगी. So you have seen when voltage drops takes place, voltage become low. Your fan, your bulb glow, है ना, weaker. So this is another question here. So these are simple questions which are asked in board exam. Now there is another question here. There are two conductors of same length. L1 is equal to L, L2 is equal to L. But their area of cross section A1 upon A2 is equal to 1 by 4. These are two conductors of same length and same material. Their cross section area are in ratio A1 ratio A2. Area cross section, you understand? 1:4. Now, how much will be the power produced? Yeah, what is the ratio of power produced when same voltage applied across the two conductors? Same voltage applied across the two conductors. So here we know again power is equal to V square by R. Voltage same. So you have to find out resistance of 2R. So resistance R1 equal to rho L upon A. R2 equal to rho L2 upon वो L ही है upon 4A. क्योंकि रेशियो जो है वो 4:1 है. It is 4A. नहीं उल्टा हो गया. 1:4. ना 4 तो होगा. A1 equal to A2 equal to 4A. A2 equal to 4A. ठीक है. तो R1 upon R2 जो है, it comes out to be what? 4 upon 1. If we divide, this cancel, ये cancel. 1 upon 1 by 4. 4 by 1. Now find the power. P1 equal to V square upon R1. P2 equal to V square upon R2. So P1 upon P2 equal to R2. P1 upon P2. R2 upon R1. So R1 upon R2, so it is also 1 by 4. So such type of question can be asked anywhere. Becoming. Now another question here. A question which is little away from you see the approach and topics which are in syllabus. We have different type of appliances, electrical appliances, heater, bulb, motor. You know what is the purpose of motor? Electric motor. We use in fan, we use in running different machines. Electric motors are used. So basically, what is the purpose of electric motor? You are not with me. Electric motor. What is the purpose of this? There is general question which a student can't answer because they are not taught and they don't learn that way also. That's why I am telling. The work, the purpose of motor is to convert electrical energy into mechanical energy. Electrical energy into mechanical energy. And I told you in one video how does it work, how does electric motor works. How does electric motor work? So actually in the magnetic field, if we place a loop in the form of rectangle or circular or any shape, when we pass current, it acts as torque and rotate. The fan rotates only because when we pass current. Now this is North Pole, South Pole. Anyhow, we doesn't rotate, that is another matter. But it rotates only when we pass current. The coil is your conductor. The coil is your conductor, and every conductor has a resistance. So some power will be lost in the form of heat. Some power will be lost in the form of heat because of resistance of coil. This is one thing. Your motor gets warm not because of continuous rotation, it is because of when we pass current through the coil along the rotation, it produces heat because of resistance. Please, you may note it very carefully. People don't know what is happening there. Now I also told you the working of electric generator. The working of generator is the same construction. When we rotate, then current is produced. Generator. In generator, we again place a coil of conducting wire. When we rotate it anyway, by using some external source, we rotate it, then current is produced. And induction of current oppose the motion. The current produced oppose the motion. So the electric motor, when we pass and rotate in magnetic field, so some current will be induced in this, and hence a potential difference will appear across the end, which will be opposite to the applied EMF, which will be equal to the which will be opposite to the applied EMF, and that is called back EMF motor. Back EMF of motor. You might have seen when a big motor starts, a motor of power certain 10 kilowatt or 15 kilowatt starts, the bulb in the neighborhood get dim, and when the motor picks up full speed, the bulb or any other device run at its usual power. Why does it happen? This is that question, that's why I am telling you here. So my question is there, I got you to. So when motor rotates, there is back EMF, so net current flowing will be I will be given by E minus E dash upon R. E is the applied EMF, potential difference. E dash back EMF. R is the resistance of winding. By every motor is made up of a coil which is placed in magnetic field. And this coil has large number of turns and will have some resistance. Heater produce heat because of resistance, and resistance is the cause of power dissipation in electric motors and other devices. So we minimize the resistance, or heat produce also power produce, you know, equal to I square R भी है, equal to V square R भी है. I mean, so how to minimize power loss in the form of heat? This is the actual power loss in form of heat. और इनपुट पावर जो है समझे कि VI होगा. So every motor dissipates heat in the form of dissipate in the form of heat. So my question is there is a question, an electric motor में लिखना हो जान दो. electric motor. Oh, electric motor draws a current of 10 ampere when operated at 80 volt. If the efficiency of motor is 60%, then find the resistance of coil of motor and back EMF when it is running at full speed. I think you have got the question here. Electric motor operate, you can say like this also. Electric motor operates at 80 volt and draws 10 ampere current. Efficiency 60%. So what is the resistance of the link बनाना होगा. 60% efficiency means by purpose of electric motor convert electrical energy to mechanical. So 60% of input power. Here input power जो है that is VI equal to 80 into 10 यानी कि 800 वाट है. Power given to motor is 800 watt. It draws 10 ampere current at full speed. At full speed. ना भाई. तो 60% efficiency means 60% goes power converted into mechanical energy, rotational energy. Then remaining heat, since efficiency equal to 60%, so heat produced equal to 40% of 800. That is 40 upon 100 into 800. So it is 320 watt. 320 watt is going waste in the form of heat. The whole power given is not coming to. Now how to find resistance? So here is the problem. We can't apply the power का फॉर्मूला हमारे V स्क्वायर बाई R भी है और पावर का फॉर्मूला I स्क्वायर R भी है. अब we should be applied to find resistance. Actually, when it is at full speed, listen very carefully. This is not written in any book here. When motor is at full speed, the net EMF will be E minus E dash. डेल्टा V जो होगा पोटेंशियल डिफरेंस E माइनस E is applied EMF यानी कि 80 वोल्ट and E dash back EMF. So we don't know what is the net EMF. बाद में करेंगे हम. So we can't apply this formula because voltage at full speed is not known here. But at full speed we know current is 10 ampere and heat loss 320. So I square R equal to 320. I is 10 ampere 100 into R equal to 320. So R equal to 3.2 ohm. 3.2 ohm. Now you are asked what is the back EMF? back EMF. At full speed, I equal to E minus E dash upon R. ये 10 एम्पियर है, ये 80 है, ये निकालना है, ये 3.2 है. What is 3.2? Resistance. So what is E dash? So 80 minus E dash equal to 32. So E dash equal to 80 minus 32 equal to 8 or 7 minus 3, 48. This is the back EMF. So net voltage remain only how much? 80 minus 40, 32. 32 will be the potential difference when across this motor when it is running at full speed. So that is why when we start big motor, initially rotation is 0, so no back EMF. So current will be drawn large. E dash 0 होगा तो large current will be drawn and which will taken from the appliances running in the neighborhood. When it is run at full speed, potential difference becomes small. Current to 10 ampere but voltage become less across this. Okay. So this was good question for you. Please note it.